Alright, so let's do this review. So remember, me doing this video here is not for you to copy, but just to use if you don't understand something or you just want to see me go through it, but you should be doing these problems on your own and then coming here, not just taking notes on what I do. Alright, so graph this log function. Oh, the graph is shown to the left. So first of all, I noticed that this is different from a regular log function. It's been moved to the left 4. Okay, the vertical asymptote. So you know a normal log function is like right along here, and the asymptote is right there. It's usually x equals 0. So that's been moved to the left like the graph has. So that would be x equals -4, and it's sitting right here. Okay. All right, the domain. So the domain is everything to the right of -4. So -4 to infinity, not touching -4. The range, it goes down and up forever. So -infinity to infinity. So when you graph this on your calculator, just remember that when you graph it, this log base 2, you press the math button. So you press the math button and you go down where it says log base. You can put any base you want. Log base 2 and then put x plus 4. Now another place to find that log is if you press alpha and, oops, let me clear this off. Alpha zoom, nope, alpha window. And the log base is right here as well, so number 5. So either way, log base 2, and I got x plus 4. Right, and so when you graph this on your calculator, remember, because this is a nice Desmos graph here, but remember it keeps going down forever. Okay, now this x-intercept looks like -3, this y-intercept looks like 2, but let's make sure. So to find my y-intercept, that's the easiest. I can go to my table and just look right there, 0, 2. So 0, 2. My x-intercept, on the other hand, might not be as easy, so let's go back to the graph. It looks like it's at 1 to -3, so I'm going to do second trace or calc. I'll do number 2, 0. And if it looks like it's at -3, I'm going to tell the calculator to start at -4. So I typed in -4, enter. Then I'm going to tell it to stop looking at, let's say, -2. So look between -4 and -2. And so see, he puts this little arrow. He's going to look right in this area and find that x-intercept. And I just press enter. I do not want to guess. All right, no, -3, 0. Okay, in behavior, as you approach -4, the graph goes down to -infinity. As you approach positive infinity, the graph goes up to positive infinity. All right, down here we have an exponential growth. Remember, it's a growth because the base is bigger than 1. And so that's growth. It's been moved down 4. Okay, so horizontal asymptote. Exponential functions have a horizontal asymptote, and this one is right here. So what controls the asymptote is this number for exponential functions, and this thing inside here for the what's it called? Log functions. Okay, so that would be y equals -4. It does have both an x and a y-intercept, so we'll find those in a second. My domain is everything, goes out forever. But my range is restricted by the asymptote down here, so from -4 up. Now I can see the things, the x and y intercepts clearly here, but let's find them on the calculator just to make sure in case they weren't. So 2 power x minus 4. All right, so again, for the y-intercept, go to my table. That's the easiest thing, and there it is, 0, -3. For my x-intercept, you know, I can see the x-intercept right here, you know, 2, 0. So if I get lucky, it's there, but let's go back to the graph and do the buttons. So it looks like it's at 2, so second trace, number 2. I'm going to tell the calculator to start looking at 1 and to stop looking at 3. So it's going to look between 1 and 3 and find the x-intercept. And I press enter, past guess. All right, so 2, 0, like we thought. All right, the left side, well, the left side of the graph is staying at -4 with the asymptote. The right side of the graph is going up to infinity. Okay. All right, down here we have some exponential equations to solve. So 3 and 81. Well, 81, I can know that 3 to the 4th is 81. That's like a fact that I know. So what I'm going to do is replace 81 with 3 to the 4th. And I still have an x out here and 3 to the x plus 5. Alright, so using my exponent rules, these multiply. So 3 to the 4x equals 3 to the x plus 5. And let's go ahead and we're going to make these equal to each other. So I got x plus 5 equals 4x. Alright, and so I'm going to solve that. Take away x. So if I take away x, I get 3x. And so x equals 5 over 3. Alright, over here I got to do a little solving first. Let me add 3 to this side. Alright, so I have 16 equals 2 to the 2x minus 6. Alright, now 16 is a power of 2. 16 is 2 to the 4th. So 2 to the 4th equals 2 to the 2x minus 6. Alright, so I don't need the 2's anymore. I just know that 4 equals 2x minus 6. Alright, so let me add 6 and get 10 equals 2x, so x equals 5. Alright, over here, this is a log equation, so remember that you can change a log format to an exponent. So this is my base, my power, and my answer. So from this format, I can write 3 to the 4th equals x plus 7. Well, 3 to the 4th is 81 equals x plus 7. If I take away 7, that comes out to 74. Okay. All right, on the back side here, this is our review problems here. My old rational functions. Remember, my vertical asymptote comes from the bottom. X can't be 5, so x equals 5. My horizontal asymptote comes from comparing these two things here, and these match. So I take 2 over 1, so it'd be y equals 2. For my vertical asymptote, I got to do some factoring. We'll factor this up, but I can tell you the horizontal asymptote right now. These match, so I'm going to take 4 over 1. And let's factor everything. The bottom is perfect squares, so that's x plus 2 and x minus 2. And I'm going to factor the top just for the fact that like maybe something will cancel. But these are also perfect squares with 2x plus 3 and 2x minus 3. So nothing cancels, and my two vertical asymptotes are positive 2 and negative 2. Alright, so here I can tell you the horizontal asymptote. The top has a smaller power than the bottom. So that's just automatically y equals 0. But to do the verticals, we've got to factor. So I'm going to pull a 2 out of this one, which leaves me x minus 2. On the bottom, let's see, 4 and 1 make these, so x minus 4 and x plus 1. Now, remember that if one of these things cancels, we have a whole, but they do not. But if this was like x minus 2 and x minus 2, then those would cancel, and I only have that for my asymptote. But it doesn't cancel, but that's what creates a whole if it did. So I got two asymptotes. One of them is at 4, and the other one is at negative 1. So go back and study, you know, like all the rules about the asymptotes. All right, my sequence, which we just finished here, this is going up by 7 each time, so I'm adding 7. So remember, that is my common difference, and my first term is negative 8. So to write my formula, I got an equals a1 plus n minus 1 times d out here. All right, so we got negative 8 plus n minus 1 times 7 over here. So when I multiply that out, I get negative 8 plus 7n minus 7. So when I clean that up, I'm going to name it an. That's the name of an explicit formula. I got 7n, and then negative 8 and negative 7 make negative 15. All right, so let's just test it out. Like for instance, 1, 2, 3, 4. This is the fourth number. So 7 times 4 is 28. 28 minus 15 is 13, so it's working. All right, 35th term. So a35 would be 7 times 35 minus 15. So 7 times 35 plus or minus 15. All right, 230. Okay, so this we just did in class just the other day or today. So I gotta put my data in, so press stat, enter, and there's no data in there. If there was, you could go to the top and press clear and enter, or you could just clear your whole calculator, you know, second plus and 712 if there's data in there messing you up. But let me put these in. So this data collected by a biologist on the growth of bacteria at the end of each hour. So the bacteria was growing. So I expect an exponential growth model, okay, which means the b value that I get. So an exponential model looks like this, y equals a times b to the x, right? That b is going to be bigger than 1. And the a should be someplace close to 250, right? Because that looks like the starting value here. It might not be exact, but all right. So my buttons, I press stat, go over to calculate, and go down to exponential regression, which is number 0. All right, go down here, alpha trace to get y1, and there's my equation. So look, you know, that's not too great, but look, this is bigger than 1. Alright, so my equation is 200 rounded 2 decimal places, 215 point, we'll say 98. My b value is 1.65 to the x. And now it says, assuming this continues, what happens at 7 hours? So it's going to be higher than 3,000. But we just clear that, do alpha trace and grab y1 and put in 7. So 7,259, we'll just knock off that because we can't have part of a bacteria. Okay, so this many bacteria. All right, and it looks like I skipped number 8. So convert each exponential expression to log form. So I got my base, my power, and my answer. So remember it goes like this, a, b equals c. So a to the c equals b, like that's the placement of it. So my base is 4, so log with the 4, leave a little space. 4, the power is here, -3, and my answer is 1/64. So my log with my base 25, power is 1/2, because that says the square root of 25 is 5, and 5 goes here. All right, down here, we're taking this log equation, which is true, and writing it in exponent form. So 2 to the 4th has to equal 16, and it does. 3 to the -3 equals 1/27, because you put the 3 to the 3rd on the bottom, and that's true. All right, 10 and 11. So this is an exponential function. It's a growth problem. So exponential functions, they have horizontal asymptotes at y equals 0. So only if you move it up or down does it change. So that number right there, that 3, controls the asymptote. So horizontal of y equals 3. It does not have a vertical asymptote. Okay. So now imagine this is moved right and up. If you move this graph right here to the right and up, it's never going to touch the x-axis. So it's not going to have one of those either. Okay. And the y-intercept. So the y-intercept is when x equals 0. So we're going to do that on our calculator, but I could put this in myself. I could put a 0 here. So 2, 0 minus 5 is -5, and then plus 3. So 2 to the -5th, that means 1/2 to the 5th, and 1/2 to the 5th is 1/32, plus 3. So 3 and 1/32, like that's going to be my y-intercept. All right, so we'll find out in the calculator, but if I do, 1/32 plus 3, that's going to be the y-intercept, I can tell you. And if you want to make it a fraction, that's the improper fraction of 3 and 1/32. All right, so let's see. Clear that off. I got 2 to the x minus 5, and then plus 3. All right, so you see it's too high for an x-intercept. It's turning up, and if we go to our table, there's my y-intercept right there, like I said it was. So we'll just round it off to 3.03. Or, you know, on the graph, you can press trace and type in 0, and you can get it that way as well. All right, determine the equations of the horizontal and vertical asymptotes. So a log function. Log functions look like this. They have a vertical asymptote at x equals 0. So when you move them left or right, that's when they change. So this number controls your vertical asymptote. All right, it doesn't have a horizontal asymptote. Now, imagine moving this graph right now. It doesn't have a y-intercept, but when you move it left, it's going to have one, and down 3. So it's going to have both of these. All right, so let's go to our calculator. All right, let's see. So we need log base 2 right here. So you can get it by doing alpha window and then number 5, or you can press the math button and go down to the log base. So 2 and x plus 1 minus 3. Oops. All right, so this graph, remember, it does keep going down, but I see it touching the y-axis, so let's just go to the table and find that. So -3. All right, and then for the x-intercept, I don't see it, but let's look here. Uh-oh, I do see it right there at 7. So we kind of lucked out. If you didn't see it, you could, what I was looking for is when it changed from negative to positive, but I was lucky with that one right there. All right, remember, if you don't, you do your second calc, number 2, and then you go over here and you tell the calculator, hey, I think it's crossing at 7, so let's start from 5 to 9, how about? And it's going to look in there and find your 0. All right, so just one more little thing to study with. Make sure you look over. Let me find the paper real quick. I didn't put it on the review, but looking at this now, I remember that I want it.
Excuse me.
Hey.
I wasn't in class yesterday because I had the AP Lang exam. So can I come after school today?
Yesterday.
Because I may not
We
be in
didn't
class.
do much yesterday, but you're not coming tomorrow either?
I may not, because I have AP Spanish.
Oh, okay. All right, I'll be here.
Okay, thank you.
Bye. All right, give me 1 second. Let me go find that paper. Okay, sorry. So this paper right here, remember we did this circuit training in class, and I would give you like a little scenario, like maybe something like this. Give you a little scenario and tell you about this percentage, and you have to write the equation and then use the equation to see what's going to happen later. So a question like that. So just make sure, read these over, make sure you know what these things are and how to figure out basically, like write the equation and then use the equation to plug in a number. Okay, so just study those a little bit. All right, that's it. Bye-bye.